Hello, we are back with Advent of Code, the 25-day coding challenge that happens every year. Every year from December 1st to December 25th. We're doing it in Ruby. It is dope, and we're doing it on stream because I want to have accountability and motivation to continue doing this. We're going into this blind. Just loaded up the code, the problem set right before we started. So let's get into it. Your plane seating system. Your plane lands with plenty of time to spare. The final leg of your journey is a ferry that goes directly to the tropical island where you can finally start your vacation. As you reach the waiting area to board the ferry, realize you're so early, nobody else has even arrived yet. By modeling the process people use to choose or abandon their seat in the waiting area, you're pretty sure you can predict the best place to sit. You make a quick map of the seat layout, your puzzle input. Seat layout fits neatly on a grid. Each position is either floor, period, or empty seat, L, or an occupied seat, hash. For example, the initial seat layout might look like this, and we have a little foot right here. Now you'll just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. Pardon me. All decisions are based on the number of occupied seats adjacent to a given seat. One of the 8 positions immediately up, down, left, right, or diagonal from the seat. The following rules are applied to every seat simultaneously. Seat is empty, L, and there are no occupied seats adjacent to it. The seat becomes occupied. If a seat is occupied, hash, and 4 or more seats adjacent to it are also occupied, that seat becomes empty. Otherwise, the seat state does not change. Floor never changes. Seats don't move. Nobody sits on the floor. How? What stuck-up people? They won't sit on the floor? What's wrong with them? After one round of these rules, every seat in the example layout becomes occupied. After a second round, the seats with 4 more occupied adjacent seats become empty again. This process continues for 3 or more rounds. At this point, something interesting happens. The chaos stabilizes, and further applications of these rules cause no seats to change state. Once people stop moving around, count 37 occupied seats. Simulate your seating area by applying the seating rules repeatedly until no seat change state. How many seats end up occupied? So I guess we're looping through this until, and every time we can run this algorithm a certain number of times, and when the algorithm doesn't, when the seating arrangement doesn't change anymore, then good to go. Interesting. Let's review these rules again. All decisions are based on the number of occupied seats adjacent to a given seat. And we're talking about the 8 directions. Oh look, there's a spammer. If a seat is empty, there are no occupied seats adjacent to it, the seat becomes occupied. If a seat is occupied, okay. So if I find an L at any point, and everything around it is empty, it becomes filled. If a seat is occupied, and 4 or more seats adjacent to it are also the seat. So if we have a hash symbol, and 4 or more seats adjacent to it are also occupied, it empties. Otherwise, the seat does not change. Okay, this seems pretty straightforward, actually. It can be a little tedious dealing with array arithmetic and everything, but that's not a big deal. I'm kind of wondering if I actually want to make this into a class at this. Maybe. Why don't we just go a little wild and we actually let's make this into a class. We haven't really done that yet. Might be fun. So let's create a few classes here. We'll create the room. I'm gonna just create a room. And let's say that input is going to be let's actually turn this into an array of arrays, so it's a little easier for us to deal with here. We're gonna generally assume that this is gonna be a square shape. We're gonna just trust that there's no shenanigans gonna happen here, right? So if these are all consistent, then the first row is going to be the same as every other row. Let's define the each that's going to return a block. That's going to yield a block here. And I'll just do I actually kind of hate this already. I already do kind of hate it. Yeah, let's just do this more declaratively instead, I think. First of all, let's get rid of all this cruft that we don't need. We're getting rid of... Why are we trying to be fancy for this one? Let's just get rid of everything we don't need. I think we are going to keep that structure, though. Well, for now, I'll be loading this example over here into sample in a minute, but not quite yet. Lines. I still do want to access this like that, though. I want to use array notation on all of these. Now, it might be interesting adjacent occupied found. Going to take our input, a row and a call. I'm very concerned because whenever I do things like this, I get absent-minded, and I get my rows and my calls mixed up, so I'm trying to be very, very careful about that. That's why I'm going a little slow here. I'm trying to think through this. So we still need the concept of the min row. I feel like there's like gonna be like a lot of edge cases. Let me actually test something real quick here. We get overflow if we go over or under. Yeah, so if I go negative, that's not good. Because that Ruby kind of like grabs things. Don't want that. I'm okay with this being nil though. Because if I'm checking for a specific value, try and simplify this part of it, because I think this part, just managing the rows and columns, can be kind of annoying. So I want that to be. So and we're gonna be okay with having nils here. If any of these are less than 0, we just return a nil. The columns are our lines. Oh no, rows are our lines. If row we can actually binary, I think. Yeah, so we don't really. So now we should be safe to always return. We can like throw negatives at this or whatever. It's not a big deal. We can throw things over it, and it'll just always appear to be a nil value, which we're gonna treat as if it's floor. Okay, so we're gonna let's take an array of values here, and we're just gonna do every direction here. So upper left is going to be row -1, call -1. Values, value at. We're going to need every combination of -1 and +1. I wonder if there's probably a better way to do this. Row +1. Pyro. Call -1. All +1. We can actually turn these into maps and flatten. Value at. Values equal to all this. Put Pyro. All. And that, and we're gonna do some post-processing. Compact. Compact will strip out any nil values we possibly can have. I don't know if that's actually necessary. We are also going to do find all. Value. Pound, right? That's what we want. Yeah, we want pound here. Let's just do a little sanity check, because we might not need the compact. That doesn't raise an exception. That find all better. We also need to flatten this first. That's right. This is going to be a two-dimensional array when it comes up, because we're mapping and then we're mapping again. So we're going to flatten that down. And we're not going to take the sum because that doesn't make sense. So we're going to count how many values we have. Okay, so this function here Oh, there's one case that we actually need to skip. We need to skip row. Well, we need to skip the current seat. Okay. I think we can actually make this a little simpler too. I like exiting out in Ruby a lot, because I think it's a little easier to read. Yeah, this is much nicer now. This is so much more succinct to read. I love this so much. Just gonna read this a little bit so I don't know if it's like this. I think this normally I wouldn't have so much of an issue with, but just with the font it feels like kind of big. I think working with ranges also might make this a little nicer. I'm not sure how tightly the dot dot operator binds though, so I'm a little worried about that. Okay, so math operations don't bind as tight. Okay, that's good. I don't know if that's actually clear. I don't know. It feels a little more dry at least. It does. Okay, I think it's all good right now. I think I'm happy with everything that's happening right now. So this should all work. We're saying this blindly without having actually tried anything yet. Pardon me, I have such a bad cough today. I don't know why. It's the dry air. Winter has come. Okay, so far we have the splitting action happening. We have adjacent occupied count. What are we ultimately looking here? You're looking for the number of we're looking for the number of occupied seats. Okay. Okay. So we're gonna need to run this. We want to test this, what we have so far. Let's get a test input here, and we'll pick like random squares here, and see if those have reasonable results for our adjacent occupied count. Oh no, we are actually been editing in problem 2 of yesterday, so that won't do either. This is already in source control, so we can. Ooh, that would have been bad. Actually rename problem 1 because we are still in part 1 of this problem. Okay, so we have function for the occupied count. We're gonna test this out now. Okay, so let's do some testing here. Looks. Occupied count. But just start with row 0, col 0. That should be this square up here, and it should return 2, because the outside boundaries we can't count. This is floor. Actually, no, it should return 0. It should. Oh, all these are always going to return 0. Well, we can test that it returns 0 at least, right? Undefined local variable or method input. 6. Alright, because we're calling this our grid. Occupied? That's not the name of this thing at all. We're just making stuff up and being ridiculous while we're at 0. Okay, that's what we expect. This is actually bad sample input for us to test that particular part of this. So we're going to need to do a little bit more before we can test. What we can do is we can test, try to create the algorithm and see if like one step of it turns it into this. So let's do populate seats, because we're going to need to run this a few times. So we're going to need our input. I think that's all we need for this. Grid. We're going to need our indexes. Grid, H, index. Actually, we need to map, because we're going to be transforming the grid. We can actually just do maps so we can worry about testing if the grid's the same or not. Our next step. Let's just see if this works, right? Okay. The things we need to test. What are the rules? If the seat is empty, there are no occupied seats adjacent to it, the seat becomes occupied. Value L. Let's get our adjacent to occupied count, because we're going to need this a few times. Have a little more. So if it's empty and there's no one around, the new value becomes shebang. Else if the seat's already occupied, and count four more, so grid equal to The value. Value becomes L. Unoccupied. Else, we just keep the value. So this should, if we run this just once, should give us the second chart here. And actually, let's make this a little prettier to print. We're actually gonna... We don't need this in the end form, but... Our grid. The PP, we have PG now. Isn't that cute? Okay, so this looks... I'm just eyeballing this real quick, and like it's the same. So that makes me think that this is a success. We're going to do this a second time. Let's do a second iteration here. Instead of calling it iteration. 2. Okay. Up, and then... Oh, and let's put a new line in between. Easier to see where one begins and ends. Okay, so this is looking similar to how this is. Okay, so I feel pretty good about this. So we don't really need to print these out anymore. We'll hold on to the PG in case we do need it for debugging purposes, but we don't actually need it, I don't think. Okay, so probably the easiest way to do this is to keep track inside populate seats to see if something changed. We're going to start off with change equals false. New grid. This guy. Changed equals true. Changed equals true. Otherwise, we're not changing, right? And up. Oh, didn't work the way I wanted to. Changed. Cool. So this should... This should be changed, right? They changed through. New group. We're just going to loop through this until it changes, and we're going to print it out each time. Add some new lines at the end of that. Pretty. Actually, that boundary line after each one of these. And so what this is going to do is it should churn through until it doesn't change anymore. So it's going to have one extra run where it does change, and then we're going to see we have here. We should have this down here. Oh, we screwed something up. Line 11, we see this. Wow, that actually was it. Okay, so for our final iteration, looks right? So we have that top line. Bang, stop, bang, L, bang, stop, bang, bang. And our last line is bang, stop, bang, L, bang, stop, bang, bang. So this. Okay, so now we need to count. Let's get rid of these print statements because we don't need these. Actually, let's just throw away our. Let's just stick with just grid. We're overwriting and throwing away our original input, but that doesn't matter. It's in a file. We never need it again, I don't think. If we do need it for part 2, then that's easy enough to address. Is there a trivial way to count the instance of the character in a string? I mean, we already have it as arrays, I guess. But we could do red, flatten, find all. Let's see what this does. 37. Okay, so we have the correct answer. Perfect. Okay. I think that we're good to just throw this against our input. God, this is actually a really big, but this is a lot of seats. But that's fine. We're just going to throw it in folder like we always do. And so you can take so many seats. Let's just run this and see if we get a reasonable count. This is taking a while. Okay. Usually I give a little rigmarole about how we have to be brave and embrace our fate and hope that it's correct, and it's no different this time. But we're just going to hit submit because I'm tired and I just want to get on to part 2. We are right, we get a gold star, we're happy, we're thrilled, feeling a little proud of ourselves. Not too proud because that wasn't too hard. So we're not going to repeat our mistakes from yesteryear, we're going to take problem 2 right off the bat, and we're going to take a look at problem 2, and hopefully it doesn't beat us up too bad. As soon as people start to arrive, you realize your mistake. People don't just care about adjacent seats, they care about the seat they can see in each of those 8 directions. Now, instead of considering just the 8 immediately adjacent seats, consider the first seat in each of those 8 directions. For example, the empty seat below would be. I'm really confused what they're asking for right now, but I think I just need to look through this. The first seat in each of those 8. For example, the empty seat below would see 8 occupied seats. I think this would be easier to see in a fixed point font, I think. Let's do it like this. So L, I see you. I see you. I see you. Okay, I see things in every direction. Okay. We need to do like the whole Queen's path, and we hit spaces, we don't care, but if we hit an occupied seat, we do care. The empty seat below would see no occupied seats, because that goes straight up. The diagonal is clear. Okay, so we're basically figuring out the Queen's path. Also, people seem to be more tolerant than you expected. Now it takes 5 or more visible occupied seats for an occupied seat to become empty. Okay. Rather than 4 or more from the previous rules. Other rules still apply. Empty seats that have no occupied around become occupied. Seats matching no rule don't change, and floor never changes. Given the same starting layout as above, these new rules cause the seating area to shift around as follows. Again, at this point, people stop shifting around, and the seating area reaches equilibrium. Once this occurs, count 26 occupied seats. Okay, so let's all the work's probably going to happen in adjacent occupied count, right? This was so simple before, now we have to actually work a little harder, I think. I think adjacent occupied count kind of needs to be replaced entirely. What we can do is we can keep on going until we find like a direction. And as soon as we hit a nil, then we know that we're good. Because value out returns nil when it's trying to look up nothing, right? When it's out of bounds. So the way we did a value out's actually pretty good for us. So there's a few different strategies we're going to need to do. Algorithm. So left, left. I don't know how that happened. -1, -1. Up. Up we go. We might be able to salvage something of this, because I'm trying to get an idea. I think maybe we just put a while inside here. Put a while in here. I like this. I like this. So instead of right now, we kind of have like -1, +1. But we actually need to just iterate different directions. Okay. I'm not really making sense yet. And this might be actually like a really cringe way to do this. But I think it's gonna be fun. So all of this is below we don't really care about, but a lot of that's going away. -1. Have to. -1, 0. And we're just kind of specifying, instead of the actual values, we're specifying where we're going to be taking a look. Now, where do we initialize what we're looking at? We initialize that right here. This is what we do. Search row equals search call equals call. Okay, I feel good about this. Bar. What we're doing is we're still gonna go next if rodir equals 0 and aldir. Ugh. We're still going next in that scenario. So we're just gonna initialize here, and now we're gonna loop for a while. Until now we're gonna do the first iteration right here. I was thinking, like, do I want to do while? I don't actually want to do while. All calder. Okay. I hate repeating this. Ruby even supported do while? I never really used a do while. I don't really use that all that often. You don't really use while loops all that often. Okay, so we basically just like break. It's basically a while true loop. So we're gonna revert back to this. While true. First thing we're gonna do is we're gonna iterate. Call plus equals alder. We're just we're gonna move along the direction. Sometimes it's gonna be 0, so it's gonna be going on a flat line. Sometimes they're both gonna be like -1, and then they go the diagonal. Value equals all this. I have enough columns here. Not so big, it's hard to tell if like my columns are unwieldy. I do have a guard marker at 80 cols, but we're nowhere near that right now. Start off, assuming that we don't see any occupied. Value equal. So much more complicated than I'm kind of sad about that. So if this ever sees an occupied thing, I don't think this is a map anymore. I don't think that we're... This has all gotten very messy very quickly. Maybe this is nicer if we make a separate function for like the given direction. Okay. Do search direction, because sometimes when problems get a little messy to look at, it's nice. It's nice to kind of like break it out a little bit. But this function is just going to be responsible for is there an occupied seat in this direction? That's all we want here. Bird. So how do I want this to work? I'm basically gonna like have a while loop that just goes until the road direction hits nil. So the states I need to care about is, did we get to the end of it? And did we find something bad? In both those cases, we want to bail out. Action. So we're doing this pattern again. Now we have a value, and now we need to test. Break out if it's nil. And we return true. Value. If it's an occupied seed. Okay. And by default, we're going to return false, as I typed the exact opposite thing. Why do I keep on wanting to say occupied? That makes no sense. That's not English. Maybe it's another language, but I don't know other languages. So that's very weird for my brain and fingers to be like, hey, we're going to say occupied over and over again. Occupied in direction. Okay, this actually... Okay, so adjacent occupied count can work now. And we can actually simplify this. False if direction 0 and all direction. We don't need to worry about that up here. We'll just say that 1 else 0. Okay. Oh, we need to actually... input all direct order direction. Let's bring this up a little bit. So many arguments. Instead of hit, let's just say found. Or or occupied. Applied. There are certain words that I tend to use when programming that for some reason I can't type. Okay, so we can keep that logic there. Get rid of out of date. This is trash. It served us well though. Had it before. We actually don't need to do any of this. Don't need to do any of this here. Because it's going to return true or false, right? And take the second map. You just double check this. Yeah, this always returns true. Latin. Where the value is true. Perfect. So this should return the number of occupied now. Okay, let's get back into get rid of all these. It now takes 5, so we should take note of that. Okay, we don't need any of this. I feel like I'm missing something, so let me just read through this quick. Or printing. Okay, so populate seats. Go through each seat. Get the occupied count. Count 0. The adjacent count. We look at 3 different directions. Occupied in a direction. Returns true. If for each direction it's occupied, it returns true. Flatten all those directions. And we just find the true values and then we size it out. Okay, so that gives us the number of occupied. And checking out the direction, searching the direction, bail out when we're not moving anywhere. You have an infinite loop here that will just keep on going in that same direction. Value, if the value is nil, we break out. Get a little more generic. If the value is falsy at all, I think down. In that case, it's going to go down to false, because if we ever exit the false, and there's always going to be a scenario where we out. If it's a hash, then we return true because we found something occupied. Otherwise, we iterate again until we hit the wall. Structure of this is really wonky. Usually, returning from inside a loop only really it's kind of cringe unless if it's like an exceptional condition, I guess. This might be. Found occupied. We initially set that to false. And we do. Oh my god. False. until bound occupied, then this bound occupied equals aggression. So we're saying a more explicit end to rigmarole. And then we ultimately return bound occupied. And that's exactly what we want here. Let's change our sample let's change our input into sample. And let's do as we did before and do one iteration and see if it looked right. Oh wait, we can actually print out each of these like how we did before. Kind of have this set up like this. It'll probably be easier. And we can just see if like the end grid looks right. Okay, let's run this and see if this blows up or not. Oh, we're still running problem 1. Let's run problem 2. Okay, so what is the end result of this? Okay, that doesn't look right. Doesn't look right at all. So our first how this changed. So for our first one, this looks right. All of them. They look good. Okay, here's where we start going wrong. Occupied. No, this is free. No, wait, this is still right. Oh, wait, but... Oh, yeah, we occupied this one. Shouldn't. Why do we do that? This is... One... 3? Add an index. When we're testing. Run this again. One. Zero, 1. This is our 0. That looks entirely correct. Our 1 looks entirely correct. Our 2. Our 2 looks wrong. Our 2 looks very wrong. Let's add a binding pry when our count equals 2. Take a peek inside and see And populate. And all makes sense. So our first value is fine. We're on first L. First L should be fine still. 1, 2. Why is that 3? That should not see 3. That's actually very odd. Maybe we should actually be inspecting each of these. What counts are coming up. Oh no, I did next. Next, and then up into. So let's just run this. See what we expect. For a hash. Expect to see 1, 2, 3. Should not see. I wonder if we count multiples if we see them. Step in here, see what's going on. Let me think about this for a second. This should see 3. Grid, size, grid, first, size. This is 10 by 10, so this actually should see 3. That's actually normal. Because we have 1 down, we have 1 diagonal, we have 1 lateral. Okay, so now we're starting with the period value. Actually, be a So we're on the LL version here. So do the same thing again. See what our count is. Okay, so we expect to see 1, 2, 3. That seems accurate to me. Oh no, I did continue. No, I do this then. Step. Let's I'm tired of having to step through. Let's actually make this. We're gonna make this a class variable. So we're all these methods are in the same class because they're always inside an object. So this will be a it'll kind of like look like a global variable. So we can do this. Even though we have a count down here, we have @count, and that's entirely different, so they don't collide in any way whatsoever. So spread this out again. It's just easier to work with the debugger in that case. Okay. So now we're always going to be starting on like our count 2 here. And just as a sanity check, take a look at our row. We have the double L row. We can do continue to zoom. We're on period. And we checked out period. Period looked good. JSON.hide count looks like this person. 3 again, okay. So that's 1. Three, okay, that does make sense. Go all the way down. There's nothing on the side diagonal. Some shenanigans. Get the not what I'm fonts here. I just want it to be like more obvious. Wider my. That's actually a bit better. And if I can page around with my cursor, that's actually a bit better. Okay. Where were we? We're at... We count at 3 from O2. 0, we're on the first L. So there's 2 on this row. Nothing on the diagonal. Nothing going straight down. But there is something on that diagonal. Okay, so that's normal. So we are now at L number 2. And this is where things start getting weird. Where it starts getting. Okay, so it's only seeing 2 here. When it probably should be seeing more. We have 2 on this row. I'm not seeing why this should be flipping over to hash. That doesn't make sense to me. Maybe I missed part of the instructions. This should be 2, and 2 stays. Just go through what the... Realized your mistake, people. Jason, they care about the first seat they can see, which is 8 directions. Leftmost empty seat. Okay. Takes a 5 or more visible occupied seat. Occupied seat. Occupied. Is it like actually like adjacency that? Is it adjacent occupied seats that matter here? Let's go through their examples here. Most empty seat would only see 1 empty seat. They only care about the first seat they see. That's the part I missed. Oh, this changes everything. Okay. They only care about the first seat they see, so we're only skipping over the periods. Oh my god, that's such a big blunder on my part. So, occupied interaction needs to change. But we're really clever with this right here, but we're actually going to need to back to something more similar to what we had before. Okay, so we're churning in any direction, right? Let's turn this back into while true. Churning into any direction. We return true if there's no value. We're not worried about being too pretty right now. We're just making the algorithm work. Return true if value hash. Return false if value. This right here, this is the line we missed. Get rid of that, we get rid of that. We should never get to that line. God, I think that's just... let's comment out our breakpoint. And let's just look and see how this develops. Let's see how the charts line. Oh god, no. That's not no. I'm actually gonna make this grow so I don't have the paging. I wish there was a command to just like break out of Binding Pry altogether, but have. Maybe there is a thing. I'm not a power user of debuggers in general. Oh. Okay. Let's see. Does the last one look right? Last one does not look right. Not look right at all. And the number is wrong as well. Okay, let's go up where we went wrong. Okay, first one looks wrong. First one looks very wrong, actually. No. Oh wait, no, I want to be looking at this. But these should all be L's. I think I have my logic reversed. L and no value should both. So, okay, that's a simple mistake. Let's run this again. Now we should be perfect. 26. That's actually the number we were looking for. And our final chart looks correct as well, does it? Yeah, no. That looks pretty. Great. Let's move on to using our real input and seeing what we get. Oh, it's kind of cute. I kind of want to see that again. Actually, can we make this go up a little bit? Oh, I guess we can't see like the entire input. Our screen isn't big enough for that. It's cool. It's kind of like compressing in though. It's actually really dope. Can I do that with an actual terminal window? I think on this I can... On. I can hardly see it, so. Add event. Old event. Boom. The problem it do. I just want like one whole screen of text to. I'm currently bigger than our thing. So if I do this, if I shrink it down a little bit and I add new lines, I can see the transformation. Shrink it down. So small, I can hardly see. I think this is actually accurate here because we're seeing our counter in a very consistent spot. It's just cool looking. Oh no, I thought that was fun. I thought that was fun how that was transformed. Okay, let's try this out and see if we have shame or not. Because an important part of encoding exercise. I don't know what's 100%. Is this? I don't know. I don't know if we're restored it to the proper size, but we're gonna throw this number in, and hopefully this is just gonna work, and we're gonna get our last our last star for today, and I can be done with this because I'm done with this problem. We get our we get our star. We get to go home, people. That's really what we're all looking for. I hope you guys all have a great weekend. I am done until tomorrow, and then we come back and we do this again. Have a great night, everyone. Have a great weekend, but also have a good night because you'll be back here tomorrow to hang out with me. Goodbye.